Here we have a problem. The rate of change of the mouse population on Henri's Island is given by the equation P equals 100 cube root of t, where t equals years. If the mouse population starts with 150 mice, assuming at time equals 0, what will be the population of mice on Henri's Island after 3 years? Well, what we have to understand is that the population, or the amount, I'll say AMT, is equal to the integral of the rate, okay, times dt or whatever. So, taking this into account, our amount after 3 years, we're going to start out with 150 mice. So here's 150 that we start out with, plus the integral of from 0 to 3 years of this equation here, 100 cube root of t. Well, the cube root is t to the 1/3 power dt. And so working across, we're going to have, after 3 years, our starting amount, 150, plus 100, and the integral of t to the 1/3 power is going to be, adding 1 to 1/3 is going to be t to the 4/3 power, and we're going to be dividing by the power we raised 2, so we're going to be dividing by 4/3. And we're going to make this evaluation from 0 to 3. And going ahead and working this out, we're going to have our starting amount 150 plus dividing by 4/3 is the same as multiplying by 3/4, so we're going to have 3/4 times 100 t, and we replace the t with 3, 100 times 3 to the 4/3 power, and we're going to have to subtract 3/4, 100, 0, there's 0 to the 4/3 power, and this is just going to be 0 because 0 to the 4/3 is 0. So we're going to be left with 150 plus, and 3/4 times 100, that's 75, 3 to the power of 4/3. I worked this out on the calculator earlier, and that's going to be 324.506. And for population, we're going to have to do what? We're going to have to round down. So we're not going to be counting this extra 0.506 as a complete mouse, even though the amount is over the halfway point. So we're going to end up with 474 mice after 3 years. So that's how we use this principle to get from rate to amount using integral calculus. Thanks for viewing.